Something strange is happening on Betelgeuse, the red supergiant star in Orion that's nearing the end of its life. In December 2019, it surprised everyone by dimming significantly, reaching its lowest brightness by February 2020 in what came to be known as the Great Dimming of Betelgeuse. Although it returned to its usual brightness later that year, this event sparked intense interest among astronomers. They focused some of the most powerful telescopes on Betelgeuse to investigate further. What they found was incredible. The star's surface is boiling, creating a fascinating cosmic illusion. To know more, stay with us till the end of the video. And don't forget to like, share, and subscribe to our channel for more interesting content on space science. Betelgeuse is a significant star, one of the most fascinating in the night sky. It was born in a stellar nebula and spent 90% of its life in the main sequence phase, converting hydrogen into helium in its core. However, with a mass about 15 times that of the Sun, it took a different evolutionary path. Instead of becoming a red giant like Sun-like stars, it evolved into a red supergiant. Betelgeuse attracts astronomers' attention because it's rare to see a star in its final evolutionary stage with the naked eye. This makes it an excellent natural laboratory for studying the processes leading up to a supernova, one of the most violent stellar events. The last notable supernova in the Milky Way was Kepler's supernova in 1604. Since then, no supernova visible to the naked eye has occurred in our galaxy. Thus, any change in Betelgeuse is highly significant. When Betelgeuse's brightness dimmed, astronomers wondered if this was a sign of an imminent supernova explosion. To learn more, they used the Atacama Large Millimeter Submillimeter Array to monitor the supergiant closely. ALMA's observations revealed that the star appears to be spinning rapidly at speeds that defy current physical predictions. This was puzzling. Why is Betelgeuse spinning faster than any other star of its age? Is this rapid rotation a sign of an upcoming supernova? Just as a supernova explosion like Betelgeuse's triggers a cascade of cosmic reactions, learning a new language ignites a burst of activity in your brain. The first sign of something unusual with Betelgeuse came from ALMA's surface radial velocity map. This map shows how different parts of an object, like a star, move towards or away from us, using colors to indicate speed and direction. ALMA's data showed one side of Betelgeuse moving towards us, blue shifted, and the other moving away, red shifted. This was essential for measuring how fast the star rotates. When these results were compared with Hubble Space Telescope data, it was confirmed that Betelgeuse is rotating rapidly. One theory suggests Betelgeuse's high rotation speed might be because it once absorbed a smaller companion star, a process called celestial cannibalism. While this can happen with red supergiants, there's no solid proof for Betelgeuse. If Betelgeuse evolved alone, its fast rotation is surprising. Understanding why this is a problem requires knowing the star's size. Betelgeuse is 15 times more massive and 1,000 times larger in diameter than our Sun. If it were in the Sun's place, it would engulf Earth and reach Jupiter's orbit. Betelgeuse is now a red supergiant, no longer a main sequence star like our Sun. As these stars age and expand, their rotation should slow down due to the conservation of angular momentum and mass loss from stellar winds. Red giants are expected to rotate at about 1 km/s, and red supergiants even slower, typically less than 0.1 km/s. Yet, Betelgeuse rotates at 5 km/s, 50 times faster than expected for its type. To uncover why Betelgeuse rotates so quickly, astronomers needed to confirm whether the observed rotation was genuine or a measurement error. They considered that other surface activities might be mistaken for rotational movement. To investigate further, they used the ALMA telescope, a sophisticated radio telescope with 66 antennas of various sizes. ALMA observes submillimeter wavelengths of light, allowing astronomers to study the hot gas in Betelgeuse's outer atmosphere. They aimed to determine if Betelgeuse's rapid rotation was actually something else happening on its surface. The astronomers proposed that a process called convective flow might be occurring. In convection, hot material rises to the surface because it's lighter, while cooler, heavier material sinks. This creates large swirling patterns called convective cells, resembling giant boiling bubbles, extending from the star's outer layer to its core. The team theorized that these boiling bubbles might be creating an illusion of rotation. Bubbles rising on one side and sinking on the other could make the star appear to spin, causing some parts to move towards us, blue shifted, and others away, red shifted, as seen in ALMA's maps. To test this theory, researchers made a computer model of a non-spinning red supergiant star with a boiling surface like Betelgeuse. They compared this model's behavior with ALMA's actual observations. Amazingly, the model and real data matched perfectly. This confirmed that the rapid rotation wasn't real. Instead, Betelgeuse's surface was bubbling intensely, mimicking rotation. This bubbling effect is so pronounced that even advanced telescopes like ALMA can't distinguish it from true spinning. Betelgeuse, the enigmatic red supergiant, has long fascinated astronomers with its erratic brightness. Nearly 4 years ago, it experienced the Great Dimming, where its light significantly waned. This event was later linked to Betelgeuse expelling hot gas, which cooled and formed dust, temporarily blocking its light from Earth's view. In 2023, Betelgeuse's brightness unexpectedly surged by 50%, sparking supernova speculations. However, this increase was found to be a lingering effect of the 2020 event, which disrupted its regular brightness cycles of 400, 185, 230, and 2100 days. The Great Dimming specifically altered the 400-day cycle, shortening it to 200 days, causing the unexpected brightening. Predicting when Betelgeuse will go supernova is complex because it's hard to determine its exact stage in the stellar life cycle. Scientists need to know whether Betelgeuse is in the helium-burning phase or the carbon-burning phase. The timing of the supernova largely depends on this. At 550 light-years away, we are in a prime position to witness this cosmic event. When a supernova does occur, the first clue would likely be a surge of neutrinos, tiny particles. The Supernova Early Warning System monitors vast quantities of neutrinos released during a supernova explosion. By detecting these early signals, we can anticipate the tremendous burst of energy that follows, making the supernova so bright it could be seen during the day for 2 to 3 months before dimming. If Betelgeuse were to go supernova, it would be a stunning display and completely safe from its distant location. However, it would noticeably alter our night sky. As one of Orion's shoulders, Betelgeuse's explosion would make the constellation appear to be missing a shoulder, with the remnants of the explosion invisible to the naked eye. People often wonder if the James Webb Space Telescope can help us predict a Betelgeuse supernova. Unfortunately, it cannot. Although Webb is incredibly powerful, it is designed to observe faint and distant objects. Betelgeuse is about 1,500 times too bright for JWST's sensitive detectors, making it unsuitable for predicting the star's precise evolutionary stage. Will we be able to see the spectacular view of Betelgeuse going supernova in the night sky in our lifetime? Let us know about thoughts in the comments down below. If you found our video informative, then do like it and share with your fellow space enthusiasts. Subscribe to our channel for more interesting content on space science and hit that bell icon to never miss an update.